So here we are, 7.2b as in boy, and there's the picture that I promised you, and we are in the process of changing this 4 to a negative. Now, if I were to multiply this whole thing up here by -4, or by 4, that would change this to a -4. So if I added -4 plus 4, that would give me 0, which would be good. But if I add this, but multiply this by 4, because when you multiply this row by 4, it's each of these terms by 4, this becomes a 4, and when you add 0 to it, now the 0 turns into a 4. We don't want to go and make this anything but a 0. We like having it a 0 there. It has to be a 0. So there's got to be another option, and that being we multiply this row by -4 to make this -4 plus 4 is 0. Okay, so that's what we're going to do here. We're going to multiply this row by -4, and we get 0, -4, -12, +20, 0, 4, -7, 18. So now we add those, and we still get 0 there. We get 0 there, -19 here, and 38 there. So this is our new third row. So again, 1, -1, 2, -3, 0, 1, 3, -5, and then our third row becomes 0, 0, -19, 38 from there. Okay, we are getting there, slowly but surely. We have one more number to change. We have to change this 19 to a 1. Once we change that to a 1, then life is good. So, what I'm going to do, since 19 is a prime number and I can't multiply anything, I can't multiply anything by 2 to get 19 or 3 by 19. What I'm going to do is I'm going to multiply this whole thing by 1 over 19. Because 1, in fact, I'm going to multiply it by -1 over 19. Because -1 over 19 times -19 will give me my 1. So that's all I have to do. I don't have to do anything with rows or anything. So let's just do this in blue. 1, -1, 2, -3. Oops. Get my wrist guard up there. Yeah, this is a pretty cool program to be able to write on the screen and talk, and I've got a little wrist guards to make sure that my hand, when it rests on the screen, doesn't move everything, especially when I'm left-handed. You know, left-handed people write upside down anyway. So, anyway, I'm going to multiply that third row by that -119. So -119 times 0 is 0. -119 times 0 is 0. -119 times -19 is a +1. And -119 times 38, this is very fortunate. Come on, erase for me. I guess it's not going to erase. I'll have to scribble that out. Is 2. In fact, it's -2. All right, so do we have what we need? We have our echelon method, and what we have is our 1, 1, 1, 0, 0, 0, and now all we have to do is put our x, y's, and z's in there. Okay, so what this looks like then, as far as the proper format, would be 1x minus 1y plus 2z equals -3. Okay, so here I am out here on this lake, and it is toward the end of July, and the reds are jumping everywhere. Kind of hard to focus when I could be fishing. Okay, and then 1z equals -2. Well, I can solve this. I just found my z equals -2. Now I put -2 in there. So if y plus 3 times -2 equals -5, so y minus 6 equals -5. I'm just back substituting here. So y equals -5 plus 6, which is 1. So now I have z, which is equal to -2. I have y that's equal to 1. And now I'm going to plug x, or y and z into this first equation to find x. So I've got x minus y is 1 plus 2 times z equals -3. So x equals 2. All right, so I have found my y, my z, and my x. So my answer is x is 2, y is 1, and z is -2. And that's how you would write your answer for that one. Okay, continuing on. That last one was the echelon method, and now this is called the Gauss-Jordan elimination method. It is exactly like the echelon, but we go a bit further. Okay, so if we have, let's see, let's just use what they've got here and try to explain it real quick without having to bore you to death with everything. For some of you, it's probably hard to say how much it takes to bore you, but some of you just open the book and you're bored. I know I was when I was taking this class a bajillion years ago. But anyway, now it's exciting, right? Okay, so this is the echelon, okay, where you have 1, 1, 1, and then 0, 0, 0. The Gauss-Jordan method does the exact same thing as the echelon method, but it continues to go until this, this, and this are all zeros. So what they're trying to do is just keep going until these are zeros. So you have these 3 zeros, these 3 zeros, in your diagonal 1. Okay? And what that does is it says x equals whatever is here, y equals whatever is here, and z equals whatever is here. The only difference is, the only thing that makes the Gauss-Jordan something that you would consider doing is you don't have to back substitute. Now, to me, I would much rather back substitute than to keep going and take the chance of making mistakes while I'm trying to change this, this, and this to zeros. Just seems like it's a lot less work to have it done at this point, say z equals -2, plug -2 into this one to find y, plug y and z in here to find x, and you're done. But the echelon method, or the Gauss-Jordan method, I'm not going to go into how to do it because it's exactly like what we did here to make these zeros, only you're making these zeros. Okay, so you just keep going. Anyway, they start giving us some examples, and the examples that they give us, like example number 2, they give us pretty much the information in a story problem in order to set this up as three systems, or a three equation system, and then turn it into a matrix. So they give us, let me just at least suggest very strongly that you write this, first of all, as your system of equations with all of your numbers and letters and then they give you x equals y plus z minus. So this is all information gotten from the story problem itself. All right, so the first thing we're going to do is make sure our x, y, and z are over here underneath the x, y, and z there. So let's go ahead and make that change so that we get it in the right format. So we have x minus y minus z equals negative 20,000. Okay, once we have it that way, then we put it in matrix form. Okay, so once you have it in that form, then again, depending on if you want to use the echelon method or whether you want to use the Gauss-Jordan method, if you want to use the echelon, you change this to a 1, this to a 1, this to a positive 1, and then left is 0, 0, 0, these zeros. If you want to continue and do it in the Gauss-Jordan, then this, and this would change to zeros as well. Okay, and that's what they did. They pretty much followed this format and took this big old matrix and went ahead and solved for it. So go ahead and follow that if you want, or just give it a shot doing it your own method. And one of the things that's really important as far as these examples are concerned is the examples are showing you one method of doing this. If you, for some reason, decide, obviously you want to find this one first. You want this to be a 1, because this row then becomes very important to find the other rows. But after you find this to be a 1, it doesn't matter if you make this a 0, or this a 0, or this, what order you make these the right numbers. Okay? The book will do them in a particular way, and that's not because there's a right way and a wrong way. It's just the direction that they choose to go. So anyway, just a little bit of information there. Now, if you do have a graphing calculator, top of page 526 gives you instructions on how to use your TI-84 in order to solve matrices without having to do all of the work. Okay, and they do that for example number 3. They give you an opportunity to plug that information, and this is 4 equations and 4 variables. This is a 4 by 5 matrix here. But again, it's done the exact same way as 3 by 4. So nothing weird, except you just have 4 variables that you're finding the answer for. So your diagonals all have to be positive 1s, and left of the diagonal have to be zeros. And if you want to use the Gauss-Jordan, then the numbers to the left and right of the diagonal that you made all 1s have to end up being zeros. So really, that's all you're doing there. Okay, so the next section has to do with non-unique solutions, and we will start that in a new video.